Coming up on the tech of a landmine.
He's a priority 1 casualty. He's definitely due for the helicopter.
Indiscriminate killers, camouflaged in overgrowth, attacking without warning, without remorse. They are lethal menaces. With new technology, brave experts, and heightened awareness, landmines can be taken out before they strike down the innocent. Throughout the world, some 110 million landmines lie in wait.
Mine incidents where civilian people get injured are up to about 50 a month.
A typical routine military tactic when destroying a house is to booby trap it.
Every month, they kill about 800 people and mutilate another 1,200. In many cases, casualties of wars that have long since been resolved.
Mines tend to get left on the battlefield and not taken away. A couple of reasons for this. One is that it takes time and resources to get the mines out of the battlefield, where it's a lot easier to drive your tank away from the battlefield than to pick up mines in a minefield.
From 1992 to 1996, bitter fighting between ethnic rivals ravaged the country of Bosnia-Herzegovina. It's estimated that after the war ended, up to 3 million unexploded mines remain strewn throughout the country.
It's going to take years and years to ever clear the mines. I doubt they'll ever clear all the mines here.
The longer mines remain a part of the landscape, the higher the death toll.
The problem is so big and so wide, so we can't demine the whole city or the whole country in just a few days or a few months or a few years.
On most fronts, metal detectors are used to check for mines, but there are disadvantages to this decades-old method. While most mines are encased in metal, some of the newer mines are plastic and invisible to metal detectors. The other disadvantage to metal detectors? They don't discriminate. Any metal object sets them off. This means a deminer may waste a lot of time carefully excavating an area, only to find a money clip or an ink pen. And so the hunt for more reliable detection systems is on.
Here at Quantum, we're developing a mine detector that detects the explosive within the mine. Previous mine detectors detect metal or metal fragments within the mine. And as a result, they have a very high false alarm rate because battlefields have a lot of metal distributed around. So by keying in on the explosive rather than metal firing pins or metal cases, we can build a mine detector that has a much lower false alarm rate and a much higher detection probability.
This technology is called quadruple resonance, or QR. The QR mine detector emits pulses of radio waves tuned to a specific frequency. The nuclei inside the explosive absorbs energy from the radio waves, causing them to align. When the pulses stop, the nuclei return to their normal state, emitting a faint signal at the same frequency as the detector. The signal is received by sensitive electronics in the mine detector and analyzed to confirm the presence of explosives. In its current form, this system is tethered to a vehicle where the radio wave generator and antenna, which receives the radio signal, are mounted. In development is a more portable version with a power source and a receiver built into a 30-pound backpack. Quantum Magnetics has also developed a large vehicle-mounted quadrupole resonance detection system for the U.S. Army. The detector is mounted on the front of the vehicle. The generator is inside the vehicle, and the antenna is on top.
This is an Army Humvee that we're mounting a mine detection system on. The system's being developed for the Army. We've used this technology at other proving grounds in Bosnia and within the US. And what happens is people can drive down a road with this vehicle and find any landmines that are on the road. This movable arm is used to position these coils over an area that we want to investigate to see if there's a landmine there. Eventually that will be changed to an automated arm, but this is the key technology here that is used to find a mine. There's a main coil, and these coils on the top are used to get rid of radio frequency interference.
Another new technology for finding mines arrived via airship in the late 1990s. This blimp is a floating mine detector. Funded by the nonprofit Mineseeker Foundation, it's rigged with an ultra-wideband synthetic aperture radar. This radar can see through heavy foliage and detect high-density materials, like those used in making mines. It can detect mines encased in metal and newer plastic mines. Computer-generated graphics provide a profile of the explosives. The envelope of the airship houses the radar antennas, and because it's a slow, low-flying, low-vibration, nearly metal-free aircraft, it can survey large areas accurately. Finding mines is just the first step. In the quest to develop safer ways to clear mines, a lot of heavy machinery is being developed. The U.S. Army Panther is a remote control vehicle that pushes heavy steel rollers to trigger landmines in its path. Another mine clearance vehicle is the Aardvark. It's 13.5 tons and has a row of 72 chains called a flail that pummels the ground with 6 tons of pressure per second. They can penetrate up to 2 feet deep, clearing a 10-foot wide swath. The flail is mounted to the front of a manned armored vehicle with the driver in the compartment at the rear. Given the right soil conditions, the machine can clear almost 10,000 square feet per hour. These machines are effective in clearing large areas such as helicopter landing sites, work grounds, and other locations central to military operations. However, they're expensive and rarely used outside of military work zones. Next on the tech of a landmine, heroic deminers go face to face with the most powerful landmines in the world. Despite many new advancements in technology, non-military or humanitarian deminers often employ low-tech methods that have been in use for decades. One reason is cost. Radar-mounted blimps, quadrupole resonance detectors, and armored vehicles come with large price tags. A second factor is sociological. Demining jobs are lucrative, and in poor countries this makes manual mine clearance good business. There's a belief that having veterans from both sides of a conflict work together to clear the countryside can have a healing effect that can't be matched with the quick sweep of a machine. Most humanitarian mine clearance operations rely on simple maps showing where armies placed mines. These maps are often provided by a UN organization called the Mine Action Center. They have branches in many war-torn countries, like this one in Sarajevo. They serve as a central database, directing mine clearance workers to suspected sites and monitoring their progress. Once the mines are identified, it's up to individuals to canvass the ground. While metal detectors are not as reliable as QR technology, they are widely available and remain the norm among mine clearance crews. The deminers normally mark off 3-foot wide lanes of confirmed safe ground as they go.
If you get a signal, you must check why wasn't the signal there.
They found something?
Yes, they loading some metal pieces in land and they want to see what they find.
The prod is inserted at a 30-degree angle. This keeps the deminer from triggering the fuse on the top of the mine.
In this situation, he find mine.
Here, the deminers recreate exactly this series of events they follow when a mine is discovered.
This premier too.
And then he withdraw all people from the minefield from about 50-meter distance.
He called me and that is all for him. That is more satisfaction.
Samar Bachurovic is a demining supervisor. During the Bosnia-Herzegovina War, he was a soldier in the Muslim forces. His specialty was laying mines.
This is too little mine to put booby trap in this mine, but you can never be sure. I must pull that mine and I must be 50 meters from that mine. I will put the hook through these mines because I'm not sure is it booby trap.
If it were booby-trapped, the 150-foot distance would protect Bachurovich from the mine's blast and shrapnel. With the fuse removed, this mine is harmless. The gruesome reality of driving over a landmine is in stark contrast from what has been typically portrayed in the Hollywood war film.
Hollywood has made it glamorous. I mean, there's been movies about demolition and you can control an explosion.
Okay, what he's doing is placing the mine right underneath the wheel, simulate the actual car driving over the mine.
And you can sit there and blow up one car and just the door off that car with explosions.
Electric blasting cap will detonate from here.
It blows up and a couple of people go flying through the air and you know, brush themselves off and go running down the road and say, you know, I'm the hero.
It'll send a electrical current down the line.
Yeah, so a mine goes off or a bomb goes off beside you, and you know, you duck a bit, a few pieces of paper fly around, and that's it. This is just a massive expulsion of an explosive energy in a very short period of time. And anybody who feels that they can control that or deal with that, that's shown to be or portrayed to be in Hollywood, is kidding themselves.
You can see here's the rear end of the car, and there's the front, which the actual mine hit on the left-hand side there. And the bodies remained over there where the fire is. So most definitely whoever was in the car is now gone.
There is a fascination with it because it is so violent and it is so impressive and it is so, a fireball appears, there's a lot of destruction, there's a lot of noise. Wow, that's, you know, that's neat. To the person who's sitting in the vehicle, the person who's in the minefield when it goes off, it's not neat.
With roughly 49,000 mines cleared out of an estimated 1 million, deminers are in a constant battle to keep people safe. Next, on the tech of a landmine, the tactics behind setting mines.
So with this one little cheap mine, you're now taking 3 men off the battlefield.
And the diversity of their destruction. Landmines come in many different shapes, sizes, and specialties. The one thing they all have in common is the element of surprise.
You cannot see them at all. It doesn't mean they're not there. It's just very surreal. I think that the threat, it's real, but it's so invisible.
And while mines are now public enemy #1 in Bosnia, during its war for independence, many considered them a means to defend against threats.
We are, and the Sarajevans are living in a minefield. You know, there is more mines than one can imagine. And it was one of the defensive weapons that was used from both sides, as a matter of fact. But initially, you know, it was used in order to try to stop what was believed to be the aggressors. And then it was turned around. So there is a lot of minefields everywhere.
That's exactly what's happening here. There's minefields and mines themselves just freckle the countryside.
One of the landmine's tactical or short-term objectives is to remove as many soldiers from the immediate fight as possible. Ironically, this is accomplished by not killing them.
People think a mine is there and designed to kill a person, but really it's there to incapacitate a person. I'll set the mine in there, and we'll put it on the instep. That's all that's left of the boot right now.
And the theory behind that is if you maim somebody on the battlefield, it takes 1 or 2 individuals to get them off the battlefield.
So with this one little cheap mine, you're now taking 3 men off the battlefield.
Whereas if you kill a soldier on the battlefield, he will normally be left there until the end of that battle.
Though there are many different types of mines, most of them work on the same basic principle. A trigger mechanism, usually activated by pressure, will push a striker through a protective membrane into a small amount of friction-sensitive chemical compound. A spark is created. This spark sets off a slightly larger charge known as the detonator. The detonator in turn ignites a larger amount of explosive known as the booster charge. Finally, the booster charge ignites the main charge. The total time for this series of explosions is less than the proverbial blink of an eye. Though anti-personnel mines are much smaller than anti-tank mines, their high degree of sensitivity can make them much more dangerous.
That's the PMA2.
PMA2 has a star-shaped fuse on top of it.
Pressure from the star tip crushes the fuse.
It's a plastic mine about the size of a can of chew.
The fuse is ignited inside the charge and off it goes.
Maybe blow off their heel, blow off part of their foot.
Okay, we'll continue on with the PMA3.
That's all the explosives right there, that little piece.
This is their most dangerous mine. They don't even recover this mine, okay?
Imagine stepping on it. That's all it takes to set it off.
3 kilograms pressure will set it off, okay? In any direction.
These are not killer mines, these are wounding mines.
This is Claymore mines.
Emerald, okay? It's the same mine as our Claymore.
This is packed with explosives.
And inside 624 of metal balls.
It's a directional mine. It sends all the ball bearings out in a chosen direction.
Another type of mine, represented here by the PMR-2A, is designed to fragment into small pieces of metal or shrapnel.
Well, this mine here is set up with a tripwire.
The 2A uses 200 grams of TNT.
This one here is fragmentation.
And the body of the mine is just straight metal.
So there'll be steel scattered all over.
This is the actual explosive charge.
So you're going to take out a lot more soldiers with this.
We never pull out the stake when for PMR-2As.
Okay, place it on top of the stake.
The stake's in the ground. It can be driven in beside or on top of a grenade to protect the spoon.
And push her down a bit.
The pin's out. When you pull that stake out, the spoon comes off, and if you have a zero delay, it'll come off immediately after you pull the peg.
He's got shrapnel, just small shrapnel. You can see the small holes throughout his body. And again, in the bottom, a lot bigger, larger ones. Probably rip right through his legs.
One of the most feared anti-personnel mines is the Prom-1.
The Prom-1 is buried all the way down.
Okay, the Prom-1 is a bounding fragmentation mine.
So that mine would actually jump right out of the ground, 0.7 meter, and set you off.
It takes 3 kilograms pull in either direction on the star, or 9 kilograms pressure to activate this mine.
The Prom-1 is usually booby-trapped with a tripwire. Once triggered, an initial charge separates the main body from the base plate. When the main unit reaches waist level, a wire pulls on a striker, setting off a spark, which detonates the main explosive charge. The mine's metal casing fragments in all directions.
For this distance, that mine would cut you right in half. Everybody here would probably be dead.
In Bosnia, mines aren't the only explosive threat. Still ahead on the tech of a landmine.
As you can see, they're a homemade hand grenade.
Some of its creatively designed cousins. When wars end, mines are not the only explosives that pose an ongoing threat. Throughout Bosnia, bombs of all kinds continue to be recovered. They are known as unexploded ordnances.
This is a munitions awaiting disposal, is what MAD stands for. It's part of the actual TDM, which is the temporarily displaced munitions. So generally the ammunition holdings for the whole camp. You can see here we have all sorts of grenades, everything from newer grenades to just the grenade body without fuse, and some of the older different styles of grenades, right down to the actual just the explosive charge that is inside the grenade. You can see that's high explosive, and caked in it is little fragments, so that's actually what causes the damage when the grenade goes off.
The Dayton Peace Accords require people who find explosives to turn them over to the stabilization forces for disposal. A lot of the explosives found are homemade.
Jury rig explosives, grenade.
They call them Kazinsa bombas.
A lot of this stuff is turned into civilian police stations.
What they do is they have a 9-volt battery that hangs around their neck.
Others are found on the side of the road.
And they touch a 9-volt battery on there.
So that one lead touches here, the other here.
And has a 10-second delay.
So it's kind of creative. We have a handful of these.
Engineers destroy the unexploded ordnance at a remote site deep in the foothills surrounding their camp.
If it's a smaller amount, we can place it in with the rest of our disposals, and our high explosive charges will just get rid of that. It'll disintegrate it.
Blasting caps are small explosives used inside a mine to trigger the main blast. Sometimes these parts are discarded. While relatively small, they pose a serious danger.
Yeah, it's probably the most dangerous thing when you get with explosives is the blasting caps right there, because that's much more sensitive. Just electricity off your body, we ground ourselves before we touch them and everything else, because it could go off. Now. Probably would take your nose and half your face right off. You might live, I don't know for sure, but they can be found anywhere. If kids found this, put them in their mouth, bit on them, something like that, you know, they're dead.
No matter the size of the mine or the way it's triggered, the crippling and sometimes fatal effects are all too often inflicted upon the innocent. But with a greater awareness of their dangers, new treaties discouraging their use, and new technologies for clearing them, there is renewed hope that the death toll will finally begin to drop, and innocent people will once again be able to venture off the beaten path with fewer risks.
You had Serbs here, and you had the Muslim forces on the other side, and it was heavily battered for months and months and months, where all the people still living here. And it was a very, very big disaster. People were living very happily here, I reckon, before the war.